As an example, it's believed that most operators of CNC equipment take better care of their personal vehicles than the investment the company made that helps pay for those personal vehicles. Okay. I know that may sound a little hard or a little harsh coming across, but that's what we're seeing. I've been in facilities where we walk up to the machine and we got to dig through 3 feet of sawdust just to be able to figure out where the problem's at. So it's about keeping your equipment clean, but it's also about keeping your operators trained in the common stuff on the machines. So some examples that we see when we go on site to do service work or installations, we can have a brief discussion about your electrical cabinets. Okay, that's where your servo drives, your PC, if you have a PC integrated into the machine, that's where all of your electrical components are stored at. It's important that those components remain running cool. And more times than not, we go into a facility where they've got an intermittent issue. And we open up the cabinet and the cabinet's full of dust. Or we see that they're using the cabinet as a place to store their lunch. Or we see that they're using the cabinet as a place to store their coats. But on most of the cabinets that we're seeing out there, they have some sort of air circulation that pushes air through that cabinet. And it's important that we keep airflow going through that cabinet, mainly to keep the components cool. The thing that I want to note on there is we do have a few machines out there that have air conditioning units on the cabinets. And the importance of the air conditioning units is they're typically set for about 100 degrees. And we've been into places where the operator thinks that's not cool enough. So they'll turn it down to say 32 degrees or 36 degrees or 50 degrees. And we go in and the cabinet is sweating because of condensation. We have condensation coming off the electronic components. We have condensation inside of the cabinets, and that's the last place that you want any moisture. That's one of the last places that you want any moisture inside of your cabinet. This image right here is a PC card that connects to a machine controller, and you should be able to see the amount of dust that's on that card. Okay, so if you have a PC driven machine, I would highly encourage you, if you don't know how to clean the cabinet out, talk with your OEM, talk with a qualified service technician. Typically what we train is a air hose held about 3 feet away from the cabinet and making sure that there's no moisture coming out of the air hose. That's the bigger part of it is keeping that cabinet dry, but keeping air moving through that cabinet is extremely important. The next thing is, let's have a discussion about compressed air systems. We see this more so in the Southeast, where somebody may take an air compressor and put it outside. And that's a good place for an air compressor to go. But if we don't maintain that air compressor, then we end up getting dirty, contaminated air. Most of your machines on the air inlet coming in will go through what's called a automatic drain, so that any moisture in the air settles. That there's a bowl that goes on the bottom of this, and that bowl will fill up with water. It's supposed to automatically drain, but there's so much contaminants in the air that it affects the plunger that opens up that drain valve. And then on this system, you can see the amount of, I'll go ahead and say it, the amount of crud that's on the filter, and that's a 5-micron filter on that, meaning that it's going to let a very small amount of particles go through that. And then it's going to get plugged up, and then you're not going to have airflow. So some things about compressed air on your CNC routers or your automation equipment is, while your machine may run with a dirty air filter going through your compressed air system, this is an example of what's called a pneumatic solenoid valve. And a pneumatic solenoid valve is typically controlled with a 24-volt signal from your controller. And inside of this solenoid valve is a piston. Okay. For a perspective on dimensions, this piston is typically 1/4 of an inch in diameter, and it moves a very small amount to open up to let the air through, and then to close the air off, and then reverse the function of the air. And the problem is when you have dirty, contaminated air, that plugs the piston up. And when the piston plugs up, it's not going to work correctly. If you consider the way a tool change works on a CNC router, if you have a dynamic tool changer, which that means the tool changer travels with the spindle, and we can change tools on the fly, there's a minimum 3 air cylinders that control the function of the tool change, plus the air going through the spindle. And so when we have dirty, contaminated air, that keeps this piston from operating correctly. It's going to get stuck, or it's going to get stuck halfway in an open and closed position. So now instead of having airflow going through one of these ports, you now have airflow going through both of those ports. And then that will cause issues with the tool changer. It will cause, if you have pop-up pins on your machine table, that will cause issues with the pop-up pins on your machine table. So we'll move from talking about compressed air to vacuum hold down systems. And I will assume that the majority of us in this group are talking about CNC routers. And the number one thing that we see when a customer calls in and says, we don't have good part hold down, we're losing parts. And of course, the first question we ask is, when was the last time you cleaned the filters? In this slide, we took a service call to troubleshoot vacuum hold down issues. And they had told me that they cleaned their vacuum filters the previous day. So we trust and verify on what the customer tells us. But when we arrived on site, there was no way that this was one day's worth of dust getting through to the filters on the vacuum pump. So if you consider how a vacuum pump works, whether it's a liquid ring or whether it's a dry pump being like a Becker, a liquid ring being like a Trevani or a Decker or Atlas Capco in that area, it all works on airflow. And when you have filters in line between the router table and the vacuum pump, which you got to have it, or otherwise you're going to destroy the vacuum pumps. You're going to overheat the vacuum pumps. When you restrict the airflow, an airflow restriction would be related to a dirty filter. And we have seen these become so dirty. In this one, the images to the right of the screen, that's on a liquid ring pump. And the filters became so dirty that there's no airflow going through there. And that's how parts are held down, is with airflow. So in regards to your vacuum filters, you probably know this, you need to be looking at the vacuum filters at least every 2 or 3 days to make sure that they're staying clean. There are some things that you can do that we'll get into in just a little bit in regards to your spool boards. And we've been bolting down spool boards with plastic bolts for about the last 10 years. When you bolt that spool board down, you're minimizing how many chips can get under the spool board and into your vacuum plenum or your vacuum table. So we discovered that when we started bolting those down, and the reason we started to bolt those down is we were starting to do a lot of systems with offloads. And with the offload device, we had some customers that had so much so much dust collection, they had very good dust collection, that the vacuum in the offload device was actually picking up the spool board. That's where they were at with the high level of dust collection that they had. So naturally, we started to bolt the spool boards down, and in turn, The added benefit of that is the spool board doesn't warp. You don't have to be pushing it down all the time. It's down and it stays flatter that way. So with that, you still have to clean your filters out, but it's going to be less cleaning if we can get the spool boards bolted down. The other important thing is we've seen this at a higher rate in Florida where the customers put the vacuum pumps outside. And outside is a good place to put the vacuum pumps, but the vacuum pumps have to be ventilated. They can't be put in an enclosed room. They have to be ventilated to get a longer life out of the vanes. If it's a dry pump, then they got vanes in them. Those vanes, when they overheat, that you'll also get vacuum loss on that as well. So one common thing that we see a lot of, and this normally happens when one operator trains the replacement operator or an operator as a backup, is we get calls with a drawbar fault. And basically what the drawbar is that's the mechanism that comes down inside of the HSK 63 tool holder, and that's what clamps the tool holder in place. Okay. When we go on site to address a drawbar issue, the first thing we do is we look at how clean the tool holders are. And these tool holders should not be clean, or they should not be used. This one, if you have a surface rust issue, if you're in a naturally humid area, if you're seeing rust come up on your tool holder, such as this picture where we've got rust on the flat part and we've got rust on the taper and we got rust on the inside, typically that's coming from a compressed air system that's not running a dryer. Okay. And now we've got moisture in the compressed air system. And when we get moisture in the compressed air system, it takes a long time to get that moisture cleaned out of there. So if you're seeing, we see this more in businesses that are on the coast, particularly the East Coast, Florida. On your tool holders, if you're seeing surface rust on the tool holders, there's a two-step process that we can put a coating on the tool holders to eliminate the rust buildup on there through the water in the compressed air system or the humidity that's in your environment. LMT Onsrud makes a product called T9. It's a two-step process, and that's a very easy way if you have an issue with rust on your tool holders. If you don't have an issue with rust on your tool holders, but maybe you see a lot of compaction of debris on the tool holder, okay? Whether you're running HSK 63 tool holders or whether you're running what's called a BT 30 tool holder or an SK 30 tool holder, if you're getting surface rust on that surface, that's going to impact how well that tool's mounted into the spindle. Okay. The bigger part of that is when you have compaction or debris on the tool holder, such as in the picture with the one that's got the rust on it, and also the one that's got the material buildup on it. On a HSK 63 tool holder, we're applying about 1,800 pounds of pressure to hold that tool into the spindle. That's a decent amount of pressure. And when we pull that tool into the spindle with the clamp set, if that tool's not mounted center, now you're turning the tool off center. That is equivalent to driving your car down the road with a 1/2-inch bolt in one of your tires. Okay. You'll hear the thunk, 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 thunk. The problem is that these spindles are turning anywhere from 16,000 RPM to 24,000 RPM. So now you're turning that tool out of balance. Okay. What can happen is when we set up the sensors inside of the spindles, if we have to make an adjustment on that, we can make an adjustment so that it's a really sloppy fit. But when you have a tool eject out of the spindle at 18,000 RPM or at 20,000 RPM, Now you've got a hand grenade that's spinning on the floor or on your machine table because we're not keeping our tool holders clean. Not only keeping them clean, but keeping the inside clean. I'm not sure if you can see down inside of this HSK 63 tool holder. We've been in facilities where they have drawbar issues, and we'll look down inside of the tool holder and we'll see debris and compaction packed down inside of there. There's a stem in the next slide. So I'm not sure how many people are running HSK 63 tool holders. It's a much better tool holder than what the BT30s are. You have better holding power. You have better clamping power in the spindle, but they have to be kept clean. So if you're curious of what an HSK 63 clamp set looks like, this is what's coming down and reaching. This stem extends, and then these 6 fingers contract. Okay. When those 6 fingers contract, then it goes down on top of the tool. And then this stem comes up, and that puts pressure on here, plus the washers on the shaft. Okay. And when we have debris and compaction down inside of here, that doesn't let the drawbar fully extend. So now we're minimizing the effective holding power of the drawbar. We've been in the situation where we ask, and when we ask questions when we're on site, we ask those questions so we can understand what's happening at the facility. Okay. When we train machine operators on maintenance of the machines, the daily maintenance is clean your tool holders every single day. We've gotten a few arguments back. Well, we only clean the ones that we use that day. Okay, so if you have a tool magazine that say has 10 tools in it, and then the office sends out something custom that uses a different tool, the machine operator, from what we're seeing, doesn't always know what the tool list is supposed to be. So the bigger part of this is take the 5 minutes every day, clean your tool holders off. When we get into a situation where we see surface rust like this on the tool holder, okay, when we go on site, we stop everything until all the tools in the tool magazine are clean. Our method, and it may be debated, it's okay. Our method is we take a piece of gray Scotch-Brite. We spray a little bit of WD-40 on the Scotch-Brite, and then we wipe the surfaces clean. And then we take some denatured alcohol or a solvent, and then we wipe all the residue off. And we get them back to where they're looking new again. If we don't do that, you will turn the spindle out of balance and you will wreck your spindle. And the spindle is one of the most, your router head or your spindle is the heartbeat of your machine. And if we don't take the best practices on keeping the tool holders clean, whether it's a BT30 or an HSK, regardless of what the tool holder type is, if we don't take the practice and keep those clean, you will run your spindle out of balance. And when you run your spindle out of balance, the bearings are going to fail. I'm not sure if anybody on here has had to replace a spindle or have a spindle rebuilt. The average cost to rebuild a spindle is running anywhere from $6,000 to $9,000 to rebuild a spindle. Okay. And that's the biggest thing that I hate seeing, is to have a spindle rebuilt, or is to have to take a spindle off and have it rebuilt. The reason I don't like that is that's money that you could be spending on something else when it could have been prevented. Now, there's other things that cause spindle failure, like not following good cutting practices. That typically leads to spindle failure, or we get an operator that puts in the wrong offset number, and then we have an impact of the spindle going into the table. But 9 times out of 10, your spindle failure can be overcome with just simply keeping your tools clean, or you're keeping your tool holders clean, and also running good balanced tools. So you'll see the picture of the insert cutter in the upper right hand corner. So all that rust on there, we know that's not balanced. That's not a balanced tool. So all that's got to be cleaned off. Really, it needs to go back to the tooling manufacturer, but these are things that we see when we go on site. And when we see it, we have to address it. And we try to train the operators, hey, you have to clean your tool holders every day. Not only do you have to clean your tool holders, you also have to clean the nose of the spindle out. And they do make an HSK 63 spindle nose cleaning tool and also a 30 taper spindle nose cleaning tool. If that's something that you would be if you don't have one of those and that's something you're interested in, you can put it in the chat or you can put it in the Q&A and we'll get you a link sent to that. Okay. So again, on tool holder care, keeping these tools clean and free of debris. I understand it's a wood shop or a cabinet shop or a millwork shop. I understand that. But take the 5 minutes every day, keep your tool holders clean, and that'll gain you some life out of your spindle. So back to the clamp set maintenance for a HSK 63. There are essentially 7 or 8 parts inside of the clamp set. You can do HSK maintenance. You can take your clamp set apart. We do recommend that when we do offer this as a service to our service customers, where if we know that there's been a tool holder issue, typically we can take the clamp set out, clean it, set it back up to factory specs, lubricate it with the correct lubrication, and continue on. And we typically, once we do the drawbar maintenance, or the clamp set maintenance, it improves the situation of the tool holding. Okay, so let's talk about some things that I've seen. We get concerns or comments from our operators that we work with. And this is just kind of a question and answer thing that when they tell us we're having problems with parts moving as we're cutting the parts out. And again, the first question that we ask is, have you cleaned the filters out to the vacuum pumps? And is the spool board staying flat to the machine table? Yes. Have you ensured there's no leaks in the vacuum system? No, there's no leaks, not that we can hear. And then, have you sealed the edges of the spool board? And there's a lot of different ways of sealing those edges up. So they answered yes. So they answered all the right questions. And then we dig a little bit deeper and we say, send me a picture of your spool board, put a flat edge on it, and let's see what the spool board looks like. So this was the picture of the spool board. Now, when I first saw this picture, to me, it indicated that the spindle was out of alignment, or tram is the technical word for it. So the spindle's out of alignment. It's not perpendicular to the tabletop in both the X and the Y axis. That's what that typically indicated to us, is that they've wrecked or they've had an impact on the spindle. So our solution, until we can get a technician there, because they weren't willing to tram their spindle, and that's okay. Some people are comfortable digging into that. Some people aren't. So we wrote them a fly cut program that fly cutted the opposite direction. Instead of going the length of the table, it now went across the table, and we still had the same result. And my question to them is, let me see your fly cutter. I need to see your fly cutter. This picture may not be easy to see, but they sent me a picture of it loaded, and I saw a little chip in the corner, and then I saw a chip here. And I said, all right, we need to replace the inserts. The bigger part of this is when you have a chipped insert on your fly cutter, and I will assume that everybody knows what a fly cutter or a milling tool is. If you don't know it, it's typically a 2-inch to 4-inch diameter cutting tool that resurfaces your spool board from the cuts that get put into it throughout the cutting action of the machine. Typically, there's 2 to 3 inserts on a fly cutter. And now we have one of them that's chipped. The bigger problem with this is when I see that, the question we ask is, how long has it been chipped? They can't give me an answer. So maybe it's been like that for 3 months. Maybe it's been like that for a year. I'm not sure. The bigger part of that is when you chip an insert and you're turning that fly cutter at say 10,000 RPM, now you have a tool that you're spinning at 10,000 RPM and it's now out of balance. That tool's not balanced. It's impossible for it to be balanced. So when you guys, if you're owners or your managers on the call, if you're looking for things that, let's say yesterday the machine was running great. And today now we have an issue. And we have an issue with the flatness of the spool board, because if your spool board's not flat, you're not going to hold parts in place. It's not going to work because you're creating a cavity under that part that is keeping that part from being sucked completely flat down to the spool board. And so the bigger part of this problem was we assumed the spindle was out of alignment, but it was simply a chip cutter. I wasn't expecting to see that. The comment was, well, the other insert is fine. Why is it not working? It all has to do with the geometry of the tool. It has to do with the RPMs and the feed rate. And as soon as they changed that insert out and they fly cut it again, you can see the result. There's the chipped insert. You can see the result that the spool board is now flat and those waves are gone simply by looking at the inserts and identifying, hey, we have a chipped insert. We need to replace that. And you can see that they had replacements already there. That's this little box right here. That's the replacement inserts. And after we did that, that eliminated their part hold down issue. So we can have a discussion. There's a lot of different philosophies out there about what's the correct MDF, medium density fiber board, to use as your spool board. I'm hoping that the majority of us have vacuum gauges on our machine tables or near our machine tables that show us what the holding power is. Typically what we've seen for the best material to use for spool boards is a standard grade of 45 to 48 pound density MDF. Where we saw this come into an issue was it became a very big issue about 15 years ago. And the issue was anybody making MDF doors that are either painted or pressed, vinyl press, thermoforming. They wanted a higher density product, often referred to as double refined and or triple refined MDF. What that means is there's more resin in that product, or HDF, high density fiberboard. And you cannot get any airflow through that higher density material. So some things that we've developed over the years of doing this, and we train every new operator in the fly cutting in the new spool board preparation. When your spool board's brand new and it's the right density, we always fly cut both sides to open the spool board up to allow air to move through. If you're not bolting your spool boards down, and it doesn't matter to me if you bolt them down or not, if your spool boards are not bolted down, that can generate some additional challenges in getting your parts essentially sucked down to the machine table. We all know that MDF is very acceptable to moisture. High humidity outside, that board's going to warp. We go from wintertime to summertime or summertime to wintertime, that spool board's going to warp. When we bolt that spool board down, and the reason we use plastic bolts is so that when we run through that plastic bolt with a cutting tool, we damage the bolt and not the cutting tool or the fly cutter. Some things that added to the benefit of bolting your spool boards down. So all of your vacuum pumps should have filters on them, and there should be a filter between the vacuum table and the vacuum pump. Okay. When we started bolting the spool boards down, the added benefit to that was we no longer have the edges warping up, and the chips were getting in from the bottom of the spool board between the spool board and the machine table. Those chips would in turn plug up the filters. And so now the added benefit to that is we now have a primary filter, which is your spool board or your MDF, before it gets to the vacuum pump. So no chips or debris can get up underneath the edge of the spool board. So there's some added benefits to that. I've seen on some of the forums where operators think that LDF is the right material to use. And I'm not going to argue that, other than we need to consider how air flows. Air is going to naturally flow through the path of least resistance. So when we talk about using LDF for your spool boards, LDF lets an enormous amount of air through that product, even without fly cutting it. It's a naturally open, naturally porous product. So if we consider when we cut a part out with the cutting tool, we now have a channel going through the parts to the table, and air will naturally flow through the path of least resistance. So your cutout path, as soon as you start cutting parts out with your cutout tool, if you're using LDF, that airflow is going to naturally go to that channel that has just been cut through the sheet. So I'm not saying that LDF is the wrong material to use. There is a purpose for LDF. Typically when we do shuttle boards, where we're floating MDF across the LDF, that's where we would use LDF as the primary board. We've had a lot of machines in the past where we had 2 or 4 spool boards that we keep up with that we shuttle across the top of that LDF. So what we have found to use as the best spool board would be just a standard grade of 45 to 48 pound density MDF. The problem with the spool boards has gotten much better, but there was a period of time where the material manufacturers wanted to stock 1 or 2 products, and the MDF door manufacturers were saying we need a higher density, we need a higher density. And I think a lot of that material issue has been resolved over the last couple of years. And as long as we can use a standard, what we have found is a standard grade of MDF, fly cut it on both sides, and then keep on going. Okay. All right, so let's talk about cable tracks. Every machine has some sort of cable track on it. And what the cable track does is, think of the cable track is the central nervous system of your machine. It's like a backbone. We have cables going through here. We have air lines going through here to get the power to the servos, the encoders, the main spindle. If you have a multi-drill, everything's going through the cable track. This was a big issue until the advent of table sweeping devices or automated offloading devices, where we're naturally sucking the chips up as we're pushing the parts off the table. So the problem was, if you have a moving gantry machine, there's a lot of them out there, a lot of great machines out there, they're going through a cable track. Your electronic components, your compressed air lines, all that's going through a cable track, or also known as E-chain, energy chain. And if we consider if you don't have an offloading device on your machine, if we consider how we're clearing the debris off of the table after we take the cut parts off of the table, if you're blowing the table off with compressed air, typically that compressed air is carrying the chips and letting it land onto the cable track. If you have a closed cable track, And a lot of machines do, there's nothing wrong with it. But those, even though they're enclosed cable tracks, you can see the compaction and the debris of the items that's getting into that cable track. For those of you that are cutting particle board or melamine, or even plywood, you could do the same thing with plywood. If you took a handful of sawdust coming off of your router, whether it's sawdust or plastic chips or whatever that is, and you get a handful of that dust and you rub your hands together all day long, just rubbing that dust in between the palms of your hands, okay? What do you think your hands are going to look like at the end of the day? For one, they're going to be red. If you do that all day long, you may end up bleeding a little bit from that action. Well, that's the exact same thing that we're doing in the central nervous system of your CNC routers. Okay. Where we see this be a bigger issue at is if you look at how you're cleaning off your machine tables, if you don't have an offloading device on your machine, you're naturally blowing the dust off the top of the table and it's naturally falling onto the cable track or the E-chain. Most of the E-chains out there can be opened up and inspected very easily. If this is a concern that you have, what I would look at doing is there's 5 or 6 major cable track manufacturers out there. And they all do a good job with labeling and the part numbers on the cable track. You can probably cross-reference that to their website and see what their proper opening up of the cable track is, because these are typically plastic tracks, and on some of the machines that we see out there, just the opening and the closing of the cable track wears the cable track out. Where we see bigger issues at is when we have companies that are cutting aluminum or brass or anything non-ferrous, and then the cable track gets compacted with aluminum chips, and the aluminum chips ground out the wires. You also need to consider that on your cabling going through the cable track, there's typically a plastic outer housing. Underneath that housing is typically a braided shield, if it's of good quality. And then it goes from the braided shield to there's multi-conductor. We have some cables in here that have, it's essentially 15 to 20 cables inside of a cable. And the problem with the dust and debris, imagine keeping your fingertips together and imagine that your fingers are the wires of the conductors. And as that cable track moves back and forth, it's putting pressure on the electrical cables and the compressed air lines, and then you get a break. But then the machine moves to another position, and then now whatever function was missing is now working. Typically, that's a momentary break in the internal cables. And with that, we've seen too many occasions where the cable track is compacted. Again, this is primarily on machines that don't have automatic offloading devices with dust extraction. That's where we primarily see this at. Okay, so some things that we do if we have to do an E-chain retrofit, and the E-chain is, I would say, is a double-edged sword, whether it's an open chain system or a closed chain system. In this picture, this is an open cable track. And the idea is, if the cable track is sized right, there should be space between the cables and the air lines going through that cable track. In this case, the cable track is actually made too small, and it's not letting the dust and debris drop down in between the cables and the air lines. And this is something that we see far too often. And when we start to see things like, we get sensor alarms, like on the tool magazine coming in. Sometimes it comes in and it sees a signal that it's in and it lets it go to the next step. Sometimes it doesn't see it. And typically what we find is we find breaks in the cables going through the cable track. If we wanted to put a monetary value on this, we had one scenario and it was this one right here. I'm going back to the other slide where we had all this compaction in the cable track. We had to replace, I don't think 7 or 8 wires or cables plus the labor to do it, and it ended up being a $10,000 repair. When we see things like that, those aren't things that we don't like seeing the customer spend the money on these things when it could have been avoided. And this was something that could have easily been avoided. And so whether you have a closed track cable system or an open track cable system, this needs to be cleaned out of here. Otherwise, you're going to have momentary issues that could lead to something much bigger. So we'll talk about drive systems a little bit. So we work with a lot of companies that have moving table machines. And in this case, this is a ball screw that's underneath the machine table. It's got a servo motor with a belt drive connected to it. And some things that if you have a machine like this, it's very important that when you clean the machine up that you don't blow compressed air under the machine table. The reason for that is this ball screw is lubricated. It's got a little drip line on it. I don't necessarily like this design, but there's literally thousands of these machines out there that have this design in them. So the ball screw is wet with lubrication. We're blowing air underneath the machine to clean the machine up. That dust gets atomized and then it sticks to the wet ball screw. So it's important that if you do have a moving table machine, that when you clean it up, you need to know how that ball screw is protected. Even with ball screws that have covers on them, that ball screw cover needs to be removed once a year so you can see and get your eyes on. So this is the ball screw that was under this cover. Okay. When we pulled the cover off, there were multiple tears and rips in the cover. And we're looking at, if you have a machine that's say, I don't know, 10 or 15 years old, there may not be a ball screw on the shelf to replace that. So you may have to send that to a rebuilder. So now you're looking from a 1-week downtime to a 2-week downtime. That's the cost of doing nothing, is avoiding that costly downtime. It's not necessarily about what it costs to repair the machine. It's about what does that downtime cost your company. I'm going to go back to this slide for broken lubrication lines. Most of your linear guides on your machines have a lubrication line going to them. Where we see this be a bigger issue is if you have a moving table machine. The linear guides are being lubricated either via grease or they're being lubricated via automatic lubrication system. And underneath the machine table, we see that the lines are getting pulled apart. And then you get a linear bearing that is no longer being lubricated. Typically, what we like to see when machines are brand new, a lot of the OEMs set the automatic oiling systems up to over lubricate so they can flush the system and get all the air out of the liquid lubrication. So then we'll turn the oilers down, but what we try to train people to look for is on your guide rails. You don't want them soaking wet with lubrication, but you also don't want them bone dry. If they become bone dry, now you're not getting any lubrication into the linear guide bearings. In this picture, it's hard to see, but in a given linear guide, there's at minimum 100 balls that circulate through that linear guide that go across your guide rails. That's where a lot of the precision comes in the CNC equipment. Well, when you start to lose lubrication in the linear guides, now you may end up getting some stutter in your machine. Now your servo system should be monitoring that load to see if the load is excessive or not, okay? And with that, when we don't get lubrication in the linear guides, then we start to get dust and debris inside of them. And then the dust and debris will actually cause the end caps of the linear guides to blow off. And then now you've got, whenever you see, if you ever start your machines up, if you see a bunch of little silver balls laying around, you've busted a linear guide and you got to find it. Otherwise, you're going to do more damage to the machine. So some things that I want to make note of on OEMs, and it doesn't matter who the router manufacturer is. Yes, I have a favorite brand, but it doesn't matter. Some things to consider from the OEMs. When investments are made, and price is important on the overall investment of the machine. Sometimes OEMs have to remove features. We don't like doing it, but sometimes we have to remove features from the machines. That could turn into a bigger maintenance issue. Most OEMs do a great job about having preventative maintenance practices in place and do a great job in training the new operators how to maintain that investment. Okay. Where we see that gap come in at is we spend a lot of time training an initial machine operator. That machine operator stays for a year or two, maybe they stay forever. But in most cases, that machine operator, when they retrain the next operator, that's where the breakdown comes in at, is they don't get the proper training. Typically, maintenance issues are not related to any particular OEM, but rather operator related, meaning that we've got to do a good job in training the machine operators on how to take care of that equipment. That's got to be the number one. It's hard to say it's number one priority because product has to get out the door, but operators have to be allowed to maintain the equipment. And the bigger part is roles change in the manufacturing environment daily. The replacement operators do not always get trained as well as the original operators. And with that, there's a whole lot more in maintenance that we can go over and cover. If you have something specific that you'd like to ask or know about, we'll go ahead and open the floor up for questions and answers. If there's a particular subject for future, some things that we're looking at doing is developing another webinar for best cutting practices. Maybe we'll do another one for best spool board or MDF maintenance. My bigger passion is when we see companies invest in equipment and we go back a year later and it looks like the equipment has been there for 20, 25 years, but it's only a year old. That throws up a lot of red flags for us. Not that we're mad at the customer. We understand that everybody gets busy, but that opens things up where, look, we need to stop and we need to put a higher importance on maintenance. Maintenance should be just as important as getting product out the door. A couple of things that can help is maintenance is easy. It's simply a discipline that needs to be developed. If you don't have a maintenance program, there's a lot of things that you can do with something as simple as a Google Calendar or a spreadsheet or any kind of calendar or any kind of spreadsheet. Your OEMs should have a list of maintenance items that they want completed on the machine throughout the day. And it's got to be more than just checking the box off saying, yeah, we did the maintenance, because there's been so many times that we've seen things such as tool holders. It's not being done. It's got to be done, such as air lubrication or oil or contaminants in the compressed air system. Those things have to be checked and they have to be monitored, and they've got to be corrected if there's an issue with that. Finally, a clean facility doesn't necessarily mean clean equipment. It's very easy to do a quick blowdown in the shop. Yeah, we cleaned up, everything's in good shape, but you've got to be looking at components on the machine. If we go back to two common things, clean, dry, compressed air, and we go back to cable track maintenance, those are the two biggest things that we see is an issue, is clean, dry air and cable track maintenance. And typically when we have electrical issues or we have a machine that is temperamental, that's the best word I can use. And it's temperamental because we have broken wires inside of the cable track. That's been some of the biggest things that we've seen, and clean tool holders.
Jim, we do have a question coming in before we jump to, actually, there's a couple questions here. Before we jump to that, we had promised to select a name for someone who would win the $300 credit towards Frost Tooling. And if you will just give me a number between 1 and 20, I will select the winner.
I'll do 16.
16 goes to Austin Wanfor. So Austin, we've got your email contact. We will reach out to you and tell you how you can collect your gift card. So congratulations.
Congratulations, Austin.
So first question that we've got here, and by the way, I know we've got 4 minutes left in the time. We are okay staying late to answer questions. If you have to go, we will continue recording. You can certainly catch other questions and answers, but we will stay for as long as there are questions. So the first one is from Texas Built Cabinets asking, when should carbon vanes and vacuum pump be replaced?
Okay, that's a great question, and I'm glad that you asked that. I will make an assumption that we're talking possibly about a Becker pipe dry vacuum pump. And what we encourage customers to do is to open that vacuum pump up. If it is a Becker vacuum pump, Becker has a very good YouTube link on how to check those. We like to see those checked at minimum once a year. Okay. The reason for that is, and when we check them, we write our name on the vacuum pumps, the date that we checked them, and what the width of that vane was. Okay. There is a minimum width that vane can go down to. The reason that's a tough question is we have machines in service for 17 years now. And we know for a fact that the customer has never checked the vanes, they've never replaced the vanes, and they still got good hold down power. But we have customers that have been in operation for 2 years and they've worn their vanes out. The biggest killer for the vanes, to get to that question, or to answer that question, is we recommend to put on your maintenance schedule every 6 months to check the vanes. At minimum, if you skip 6 months and you go a year, you got to check them. You got to know what's going on inside of that vacuum pump. What will happen is those vanes get smaller. They'll come out of the slots, and then now you've got a pump that is running out of balance, and it's going to vibrate. So the short answer for that is check your vanes if you don't know how to check them. And if it is a Becker vacuum pump, you can put a note in there and we can send you a link to the YouTube that Becker has on that. It's about 10 minutes to check them. If I was the owner of the machine, I would want them checked every 6 months, because then once they start getting close to that minimum distance, you know that you have to schedule that time in and you have to budget that money in for that vane replacement. Very simple to do. Very simple to do.
Right. Jim, I'd like to unmute Axis RM Inc. in order to ask the next question, because I don't have the knowledge to interpret it for you. So okay. Axis RM, I'm hitting a button that should, hopefully will let you unmute.
Yes, can you hear me?
Yep, there you are.
All right. Just that I was stating possible, scenarios what you could cover in the future.
Okay.
Gasketing for specific parts, dedicated spool boards.
Okay. Great. Thank you. We appreciate that.
Thank you, Zach.
Definitely.
I know Zach.
Hey, buddy. Doing a good job.
Zach runs a pretty good CNC job shop.
Thank you.
All right, Jim, the next question is from Alan Lefebvre, asking, how can we lubricate the HSK clamp on the spindle?
I like that question. I'm not going to say it's impossible, but it's not easy. The only thing that you could do if you determine that that does need lubrication is you could get a little epoxy brush and put and the thing about the lubricating of the clamp set, over lubrication is going to be a very bad scenario. Okay, because you've got to consider that tool holder and the amount of dust and debris that's around that tool holder. Now, most spindle manufacturers will have what's called an air purge that's constantly pushing air through the spindle. That's why when you maybe walk by your machine, you hear that little air hiss. That's an air purge going through the spindle to be forcing air through the spindle. To answer the question, the only thing on how you could manually lubricate the drawbar is you can't lubricate it correctly without taking it out. And that can be a complicated process. I don't want you to be afraid of that process, but it can be a complicated process. You could take a little bit of the Metaflux lubrication, put onto the tip of an epoxy brush, and then you could activate your drawbar. You should have a push button to activate the drawbar to extend it. And when it's extended, you could coat just the tip of the cone with a little bit of lubrication. Some things that we've done and seen in the past to get somebody out of a pinch. And I really don't want to say this, but I'm going to go ahead and say it because I know things have to happen sometimes, is you could take a little bit of 3-in-1 sewing machine oil. It's a high temperature lubrication, just a very small amount, and you could brush that up onto the cone and also the fingers, but you don't want to over lubricate that clamp set. So I would not recommend doing it. Yes, I have made that recommendation as a short-term fix. But to do it correctly, that clamp set's got to come out.
Awesome. It's clear that Jim is part accident investigator and has tremendous knowledge to give you precision details around things that you need to do. So certainly appreciate that. We've got a few more questions in queue. Understand if you need to leave, by all means, appreciate your being here today. We've already got some suggestions for future webinars. Since you're in our email list, we will communicate next one's coming up and some topics. We might even reach out to you for just some direct feedback on this and any other suggestions for future webinars. So watch for those emails. Next question we've got is, can you talk a little bit about vibration monitoring and thresholds?
Yep. So we work with a few manufacturers of sensors, and these sensors typically go on the side of the spindle. And we've been working with, I guess you could call it sensor technology, for about the last, I'd say, 8 to 10 years. And we've seen a lot of revisions in that. If that's a question that, and we may end up having a class solely related to just spindles and spindle monitoring. So things about thresholds, the threshold is going to have to be established by the spindle OEM. I know that may sound like I'm deflecting that question, but different spindle manufacturers have different thresholds, okay? When we start talking about spindle monitoring, the nice thing about spindle monitoring is typically that's going to push information to the cloud or a cloud-based system. And we can see possibly, not possibly, we have seen where we're running a cutting tool that is not properly balanced, okay? And with that, that's going to cause excessive vibration in the spindle and the tool holding power. And with one of the manufacturers that we work with is a company called GTI, and they have a really nice system It's got a iPad interface with it. He may have changed that to a Android based, but he's running it. He's been running an iPad with it, and it shows the spikes in the spindle. And we've even seen things in spindle spikes doing a tool change. If you have a tool rack on your spindle, maybe the positions aren't set right for it to change into every pocket, and that's putting excessive force on the bearings, and the sensors are picking up on that. So if you consider a tool magazine where the tool magazine comes in from the side or the front, the force of that tool magazine coming in is actually putting excessive load on the bearings, and we can see that in the spindle monitoring software. As far as thresholds are concerned, on a lot of the machines that we deal with, we set basically a 2 or 3 second threshold that where if the spindle spikes and it stays above that spike for 2 or 3 seconds, it's actually measured in milliseconds. When it stays above that spike, we're sending messages to management, we're sending messages to support teams, so that, and we have a timestamp on that, so we know when that machine was being ran, and what, we don't know what tool is being ran, but we're picking up that there's an abnormality in that cutting tool that's being ran. We can also pick up on incorrect lead in and lead outs into the cutting part as we're diving that tool into the part. Typically, when we constantly plunge the tool in and we're not leading in with the ramp angle, we see that be a big spike on the spindle. It's momentary, but then once the tool gets to full cutting depth, that goes away. Was there a specific question about the threshold and how long you would let the spindle? That's what I'm assuming the question is that we're talking about how much time do we allow it to run before we start either sending messages out or we shut the spindle down? Was that the question about the threshold?
Yeah. Can you hear me?
Yep, I got you.
Yeah, we were just starting to measure our vibration of our spindles, and I'm picking up a lot of bad tools, but I'm not sure I'm in the correct spectrum. Like it's a 15 horsepower Anderson spindle.
Okay.
And I think we're in the, I don't have the tool in front of me, but it's a handheld device with a magnetic sensor. And I think I'm measuring between 100 hertz and 1,000. Am I in the correct spectrum there?
I think you're close. And what I'd like to do is, have you spoken with Steve at Anderson about this?
Yes, I have. I don't remember what he said.
Okay.
But he's the guy to talk to in order to get that correct range.
Okay. What was your name again? I'm not seeing you on I see you on the screen, but I don't have your name.
Yeah, my name's Andy. I'm at Norwalk Furniture here in Ohio.
Okay. And what spindle monitoring device do you have? Is it Northland Tool?
No.
It's fine, Andy. It's fine.
No, it's a handheld device. We found it on the internet.
Okay.
Probably cost a couple grand, but
yeah, I've got one of those devices out in the shed right now. And the reason I smile about that is it sounds familiar to the same device that I have. And the problem with that is the best thing that you can do, if we're not pushing information to the cloud on your spindle monitoring, is get a baseline reading and establish what that baseline is. So the best thing that you can do is, if you have that device, is when the spindle's brand new, put that on there, and that becomes your baseline. Some things, whether it's an Anderson machine or somebody else's machine, some things where we've seen pick up on additional vibration. So you have a dust hood around your router head that moves up and down, okay? And when you connect that device to the nose of the spindle, if you tap on the dust brush a little bit, you'll see that puts spike in your frequency. Also on the tool magazine, we've seen, and this is a maintenance issue, we've seen where the tool magazine is loose and the sensor is picking up on that dust cover or that metal shield over the top of the tool magazine. That's flapping. It's not flapping in the wind, but it's vibrating a little bit, and that picks up in the sensor reading as well. What kind of work are y'all doing there? Are you running any kind of large custom shaping tools or anything like that?
No, we cut 7/8 plywood all day long.
Okay.
We have changed quite a few tools because of that vibration monitor.
And has the situation gotten better, or has it stayed the same?
Well, we're not replacing spindle motors every year, so yeah, it's getting better, quite a bit better.
Okay. Okay.
Thanks for the question, Andy.
I'm sorry.
I just want to say thanks for the question. We do have a couple more if it's okay to move on.
And Andy, what I would like to do is we have your email address. I'm going to reach out to you in an email and let's get you the answers that you need, because I am very familiar with the Anderson product line. We have provided and supported that machine or their machines over the last 17 years. So if there's an ongoing issue, I want to get that relationship established with you. Okay.
Okay. Yeah. Thanks.
Yep.
Andy, if you'll make sure you drop your email in the chat, I'll make sure it gets to Jim.
Yeah. Yeah, I will.
Okay, great. Nathan is up next with a question. A little bit of detail first. He says, I recently moved my air compressor, air dryer, and vacuum into a double drywalled and rock wall insulated room. Has an air supply and a high velocity thermostatically controlled 8-inch exhaust fan. With these precautions, I'm able to keep the room hovering at mid to high 90 degrees Fahrenheit when everything is running. What are your thoughts on that temperature or a target temperature?
Great question. 90 degrees is not bad. However, when you consider the internal workings of an air compressor and your vacuum pumps, whether they're dry pumps or whether they're liquid pumps, you consider the internal temperature of those components, they're probably running fairly warm. If I understood the question, is you do have airflow going through that room?
That's how he described it. He's got air supply and high velocity thermostatically controlled exhaust fan.
Okay. If we could bring that down 10 degrees, that would probably improve the life of your compressor and your vacuum pumps. But what I would encourage you to do is pick up, and you probably have one, because it sounds like that you're really concerned, and it sounds like you've taken the right steps to protect your vacuum pumps and your air compressors. If you don't have an infrared heat gun that you can get a temperature, maybe monitor the temperature of the motor, maybe monitor the temperature of the actual part of the pump and see what that looks like. Now, the bigger vacuum pumps and the bigger air compressors will have thermostatic shutdowns on them, and they'll shut down naturally if they overheat. I really like what you're saying and about the effort that you made in keeping air moving through that building. And that's the number one thing, just keeping that hot air pushed out of the building. 90 degrees, I'm not overly concerned about, but you need to put an infrared gun on some of your motors in that room, and then also on the actual pump part or the compressor part. And typically those are going to run 200 to 220 degrees is where those are normally going to run at.
All right. You ready for the next one?
Yep.
Paul, you've got a question here. I'm not exactly sure how to say it, so if you're okay, I'd like to unmute you and let you ask the question to Jim.
Sure. I just was wondering on the fly cutter, I guess this was one of the earliest topics, but talking about that chip in the in the fly cutter. It skipped the A, the tram looking effect that I had been surfacing my spoil board, and then a tech was here and rotated the insert knives. And after the knives were rotated, it started having a very slight ridge. I mean, it's you can feel it slightly enough to, I was worried about vacuum leak or also the tram because I was wondering what happened to if it was a tram issue, if there was something between when he had switched the knives and when we'd run the fly cut, because we didn't do it immediately after he had rotated or he'd done the service. He kind of was in and out, and it hadn't needed to be cut until sometime after that. So does that make sense? Can you hear me okay?
It does. Yep. Yep. I'm hearing you. So some things that you can look at on your inserts for your fly cutter. And then after I explain this, I'm going to back up and then ask you some additional questions. Okay.
Mhm.
There's a lot of different manufacturers of fly cutters out there. And the bigger part of this is if you accidentally use the wrong inserts that are not matched up to the body of the fly cutter. And what I mean by that is when you screw the insert in and you tighten it down, if that insert rotates at all, it's not going to be flat. Now, we work with some of the fly cutters out there where when you tighten it down, it naturally pushes the very tip of the tool out to the lowest point. So now instead of using the flat part of the insert on the fly cutter, we're only using the tip of the fly cutter. The problem with those is it's almost impossible to get either 2 inserts or 3 inserts set to where they're all the same. And then that creates a non-flat spool board. When we see that, what we try to do is we take, and I don't like doing this, but we take the fly cutter and we put it down on maybe a piece of 6" by 6" melamine, a known flat surface, so that when we tighten the inserts up, you can see the light under the insert. And if you see light under the insert, you need to loosen it and make sure that that insert's getting mounted flat. Does that make sense?
Yep, 100%.
Okay. So the question that I have for you is, after you fly cut, does your spool board look like vinyl siding?
I mean,
With
yeah,
the
I can,
ridges in
yeah,
it?
not,
That's
I mean,
extreme.
obviously not to that degree. I mean, I think that, so at the rear of my machine, if I was, it's a BSE 5x12. So the operator side, and we're operating it in the length of the machine. So the rear of the machine, back of the Y-axis is the high spot, and the front of the machine would be the low edge. But when I talk high and low, I mean, it's like maybe less than 1/10 of a millimeter. Can you hear me okay? I'm sorry, sir.
Yep. Yep. I hear you loud and clear. Yep.
Okay.
Okay. So it sounds like you still may have an issue with the spindle not being in alignment. That's what it sounds like. Do you do anything with shaker doors?
No, we only do melamine. Well,
Okay.
just panel processing, so cabinet parts and closet parts. So we
Okay,
really
perfect.
aren't doing a lot of geometry.
Okay. The bigger, with cabinets and closets, the bigger part of that is where it may come up is when you send that part through an edge bander. And if your spindle is out of alignment, that means your cut is not square. Now, most people are running pre-mill on their edge banders, and that
Yeah,
can take out a lot of that issue.
sure.
But it sounds like to me that your spindle could use a little bit more work in getting it lined back up. Do you have the ability to change the direction of how the fly cutter goes across the table? Do you have the ability to do that?
Yeah, honestly, I had my fly cut program when I first wrote it myself going the wrong direction as my I had a a point-to-point machine before, and I had a beam saw. So when I went to flat table, I wrote my surfacing program in the Y direction. So I switched it over to the X, and it was not cutting, like it was cutting fine. And then that's what I'm saying about the insert tooling. So I'm gonna just, take it out and visually inspect it, and then if it's got an issue, I can switch back to my Y direction spoil board program to get rid of those
Okay.
ridges.
Okay, because the other thing that you could do is, so in one of the slides I showed a board going across the top of the spool board. If you could take a straight edge, like an old school straight edge ruler that's maybe got 24 inches in length, and you put that down on top of there, if you see any light coming through that ruler and you see high spots, but then you also see light coming through the back edge of that ruler, that's an indication that your head is out of alignment. Now, is it out of alignment enough to shut you down until you can either get it realigned or have a technician come in and realign it? That's the question that I can't answer.
Yeah, I understand. We run parts, like, I mean, like it's full jobs. I do have kind of like, an off the books support guy, and he was saying that if it was a tram based on, the measurements that I kind of shared with him, and, a couple troubleshooting things that we talked about. Because I didn't even know about the cutters until you mentioned it in this presentation, but he said it wouldn't have an impact on really part size or anything until it got to like some higher tolerance. I don't remember the number he said, but I was well beneath that. He's not that it's perfect, but it's not going to take me out. And of course, like you said, um, as far as all of this is the health of the spindle and the machine. So best practices is really comes down to money. So getting a technician or using hydros or whatever the next step up to maintain the length of the longevity of the spindle.
Yep, you said that very well. And the bigger part of that is if your spindle is out of tram or out of alignment. In the old days, we called it sweep. We would sweep the spindles in. You can run and you can put all the time, energy, and money into better tooling, into better tool holders. But if your spindle's not in alignment, it's not really going to matter. So, but that's the alignment issue is, how do I want to say this? The alignment issue is really on what you're accepting as good quality. And that may sound rough of me to say it that way, but we have customers that will cut a part and it looks like they cut it out with a chainsaw and they're happy with it. And we have customers that we give the most smooth edge on the finished part and they're happy with that. And so that's why it's tough for me to answer that question.
Yeah.
The
I
bigger,
understand. I mean, go
ahead.
Well, I was just gonna say, I mean, going piggybacking on that statement is that, in general, I mean, this is woodworking typically. I guess I don't know. I feel like this group is all from this woodworking invitation, but I understand because guys are trying to talk about measuring their table saw fences within square or whatever of a thousandth of an inch, but wood has greater, flexibility than that, even just in a so the parts and pieces, I think the tolerances there would be within whatever industry standard. And I just want to make sure the tool works well. And obviously the parts are coming out the right size. And since we're not doing the MDF shaping, I don't really know what the impact would be on like pocketed doors or profiles and stuff like that until I get to that level of production.
Yeah, I think the bigger thing is if that problem gets any worse, you're going to see an issue with part hold down.
Okay.
Because you now have a cavity when your spindle's out of alignment, and when we fly cut the table, if you see the ridges in the tape, now sometimes you'll see the ridges, but you can't really feel it, and that's simply the overlap of the fly cutter overlapping the last cut that it made. Okay.
Yeah, like the fuzz. Yeah.
Yep. But when we see a defined ridge that represents what I'm going to say vinyl siding, that low spot in the spoil board, you're not going to have any vacuum there. And that's actually going to create a vacuum loss at the end of the panel. So that's
Yep.
where if you begin to lose a lot of parts, again, my first comment is going to be clean your vacuum pump filters. The second one's going to be, is the spoil board bolted down? And if all those answer yes, and then I'm going to want to see a picture of the spoil board after it's been fly cutted. And typically on a high quality picture, we can pick up if we've impacted or if the spindle's out of alignment.
Okay.
But the guys that are doing MDF shaker doors, that spindle has got to be in alignment.
Yes.
Otherwise, there's a lot of other headaches that come across with that.
Thank you so much.
Yep, thank you, sir. Great question. I appreciate that.
All right, we've got 4 more questions in the queue, Jim. The next one from Texas Built Cabinet says, it's not necessarily maintenance related, but is there a recommended max RPM to run tooling at? Most data sheets stop at 18,000, but our router can run at 20,000. Is there even a benefit to running at 20,000 RPM?
Okay, great question. Very good question. We get that a lot from either new operators or even experienced operators. So let's talk. This may come across bad. If it does, I'll apologize up front for it. Let's talk about race cars. Just because a race car can go 7,000 RPM doesn't mean you should run it at 7,000 RPM all the time. With that said, a lot of this is going to come with the experience of running a router, and you'll begin to understand what sounds normal and what doesn't sound normal. If we're talking about cutting wood parts, and I'll make the assumption that's what we're talking about. We're talking about cutting wood parts. If we're talking about cutting plastics, that's a whole nother conversation. When we naturally max out the spindle RPM, there's no more that spindle can give if we're running it at max RPM all the time, okay? There's not necessarily a danger in that, but most tooling manufacturers should spec out what the maximum RPM of that cutting tool is, okay? If they are not putting the max RPM on there, that would be a concern for me. If we talk about having custom tools made up for shaping and profiling, we insist that the tool manufacturer of that special shape cutting tool provides the maximum RPM for that tool. Because the last thing I want to do is run a tool too fast and then either burn the spindle up or the cut quality doesn't make a change. Typically what we've seen when we're cutting wood, we get into a whole nother issue of spindle RPMs. And that issue is, if we're running the maximum RPM, are we running the maximum feed rate for that? A lot of people will tend, and I'm not saying that this is the case, but a lot of people will crank up the spindle RPM in order to get a better cut. But when you naturally, and that's just us as humans, is we're not, oh, I need to go a little, I need to increase the RPM a little bit because faster's got to be better. That's not the case. If we're talking about running compression cutters through wood and we increase the spindle RPM but don't increase the feed rate, we are now generating a massive amount of heat in the cutting tool. That heat gets translated to the bearings of the spindle. The bearings of the spindle may tolerate that, but the lubrication in those bearings, the lifelong lubrication in those bearings, that's where the bigger issue is going to be. So I have to default back to, if the spindle manufacturer is not putting a recommended RPM on the tool, or they put an RPM of a maximum RPM of 18,000. That's the maximum you should run that tool at. It deals with the balance of the tool and what that tool was balanced to and what RPM it was balanced to. Does that make sense? Did we lose them?
I see him there. It's Texas built cabinets. Give us a thumbs up if that makes sense. Cool. We're good. All right. Let's see here. Next question is about wobble in the cutting. When he cuts long lines and 3/4 material, the issue doesn't present when cutting thinner materials.
Okay. I'd like to see if it's possible for you to email me a picture of that, what it sounds like, and not knowing, it doesn't matter what machine you have, okay? From the entry-level machines all the way up to the 24/7 machines, it doesn't matter. Things can happen, and it sounds like you may have some backlash in one of your axes, whether it's a rack and pinion type drive or whether it's a ball screw drive. It sounds like you've got some backlash, and it may be something. If it's a rack and pinion machine, it may be re-engaging the gear. Some things that we have found in checking these items is a magnetic base and an indicator. And we zero out the indicator on both sides. If it's a traveling gantry machine, we'll indicate both sides, and we'll do a simple push-pull test, meaning that when we zero the indicator out, we'll push on the gantry a little bit, or we'll pull on the gantry a little bit. Every machine, you will have a slight amount of movement. The bigger part of that is, does it always go back to zero? If it doesn't always go back to zero or the same number, then you've got backlash in that particular part of your machine. It could be the x-axis, which OEMs have labeled the length of the machine X, and some of them is labeled the length of the machine Y. There's not really an industry standard on that. But if it's a traveling gantry machine, you're typically going to have two motors that are working with each other to make that gantry travel the length of the machine. And sometimes those motors can get in a bind and they loosen up. And there should be a mechanical way to re-engage those motors a little bit. The danger part of that is if you over tighten or over engage the rack or the pinion gear into the rack, if you over engage that and put too much pressure on it, then you're looking at getting an overload on that particular servo motor. And so the first thing is to do a simple backlash check. If you have a traveling gantry machine, you do it on both sides of the gantry, and then you can put the indicator and the magnetic base on the gantry and go across this way and zero it out, and then push pull on there. It sounds like you have movement possibly in one of your axes on the machine is what it sounds like to me. Great question.
All right, we're coming up towards the end of the questions. The next one is, what's your feedback on using dust nuts?
Dust nuts. So you're talking about a dust cover that covers the collet, right? Covers the face of the collet. That's what I'm going to assume a dust nut is.
Yeah, his name is also Jim, so I'll give him a request to unmute if he wants to add a little bit more.
Okay. So what I think he's talking about is there's a cover that can go in your tool holder. You've got a collet, and the dust nut covers that collet so that you don't get a bunch of dust compacted into the collet. I think they're great systems to use. However, I think it builds possibly a false sense of security. Well, I got the dust nut on there, so there's no dust that's going to get in there. And when we go to change tools out, we break a router bit, or we need to put a sharp router bit in. That could make us lazy in doing that properly, meaning when you break a tool holder down to change a broken tool or to replace a tool, you don't simply loosen the nut, pull the tool out, put the new tool in, and clamp it back up. That's kind of the ideal process from what I think is behind the dust nuts on the collets, okay? The problem with that is you're still going to get dust inside of that collet from the top side of the tool holder, because all the tool holders typically have a hole that goes all the way through them, unless it's a BT30. But all most HSK tool holders, I'd say 95% have a hole that goes all the way through those. And that's so that we can continually blow out the top of that tool holder whenever we do a tool change. I think it's a good idea. I like and we have customers that use those, but for me, it kind of builds a false sense of when it's time to change that tool out. Are we breaking the entire tool holder down and cleaning it all out? Or are we simply just using it? We loosen the collet, take the old tool out, put the new tool in, and we never do an internal inspection. It doesn't take that much longer to completely break a tool holder down and clean it out, and you'll get a lot better cutting results as long as the inside of that tool holder is cleaned out, whether we're the collet mates or whether we're the collet nut mates too.
All right. For this next question, Aaron's online as well and said he'd like to weigh in on it either before or after you, Jim.
Okay.
And so
Go ahead, Aaron.
I'll read the question and you decide who goes first. And for those who don't know, Aaron Cavanis is also with Diversified Equipment Supply. He's a field technician, correct, Jim?
Yep.
Okay, great. All right. So the question is very simply said, can you explain vacuum differential?
Okay.
You want it or you want to give it to Aaron?
Aaron, you want to answer this one or you want me to?
Let me unmute him so you guys can weigh in. All right, Aaron, you're unmuted.
Yeah. Vacuum differential, I imagine he's just asking a question about how do we, explain exactly how to measure the vacuum hold down on our machines. And if I'm correct about that, that's how I was gonna answer it, which is it's good to get a baseline of your machine when nothing is on the machine and have your vacuum activated onto the machine. You should have a gauge that gives you a reading. Most of the gauges tend to have a inches reading on it and a millimeter or a centimeter reading on it. So you kind of have to look at the gauge a little closely to see what it's reading. But for our sake of our conversation, I'm going to stick to inches. Typically, we'll see with nothing on the machine somewhere around a 5-inch on the gauge with nothing on the machine. When we load up our board on the machine and reactivate it, that's going to increase. So we'll go from 5 to, let's say, 15. That lets us know that we have 10 inches of hold down on top of the board. That 10 inches is representing water. So that's considering as if you have 10 inches of water sitting on top of that board all across it. And when you have that information, if you do the math on it, every inch for a 4x8 sheet that you can increase the vacuum pressure is about 170 pounds that you add to sitting on top of that board, which is why it's important to understand your gauges, understand how your machine's working. You can tell when it comes time to change filters or when it might be time to inspect those vanes on your vacuum pump. If you know a good baseline as to this is what my machine was running when everything was cleaned, when I knew my vanes were working, and I had good gasketing underneath my spool board, and everything was right. And then you can kind of have that baseline. We've seen where the vacuum differential, that pressure difference, can be drastically affected by not covering up parts of the spool board that are not being covered by a board. So some CNCs, let's say, is a 5x10 table, but you throw a 4x8 sheet of plywood up on top. So you have a 1 foot by 10 foot section that's going to be uncovered. Just putting something over that and blocking it up can increase that vacuum differential tremendously. And quite literally, we've seen it double your hold down pressure on that. So I imagine that was the question about vacuum differential, and having a working gauge and understanding how that works gives you some great feedback, especially if you have parts moving, as to why those parts are moving.
All right.
So if we talk about Aaron, the question I'm going to return to you. So if we have a completely open spool board down on the machine table and we're at, let's say 20 pounds of pressure and 30 pounds being the max, that indicates that we're not getting proper airflow through the spool board. Is that accurate? Is that what you're saying?
Just you
Meaning
have
that
to
the
know what your
higher-
baseline is.
Yep.
Because when you put a brand new spool board on your table, you're going to see a much higher beginning number when you turn it on. You're going to see something that might be 5 or 8 inches of just trying to get through that brand new spool board. And then as you get a spool board that gets thinner and thinner, that first number is going to change. It's going to get lower and lower. And it becomes more and more critical that you cover up any open sections of your spool board as that spool board gets thinner. That goes up. But as the spool board gets thinner as well, you're going to see that the difference go up. So where you went from 8 to something like 16, you're going to see it go from 3 to 16 if you're covering everything up. So you'll get better hold down as the spool board gets thinner if you're doing things correctly. But that's a moving number. So you can't just pick it one time and think it's going to stay the same, because as the spool board gets thinner, that beginning number gets lower. And your gauges are all, like I said, they're going off either inches or centimeters or millimeters. They're going off a measurement. And just imagine in your mind that there's water sitting on top of that board, however much that gauge is telling you, whether it be 10 inches, 20 inches, whatever your gauge is showing you, that's an imaginary water weight sitting on top of your boards.
Good way to put that. Thank you.
We're clearly seeing enough questions come in about spoil boards that I'm sensing that could be the topic for the next webinar here. But we do have a few more questions in queue. I do want to be respectful of your time, Jim, and everybody else's. If we can't get to the questions live, do you want to respond to people via email, or I can keep feeding you some questions at this point? But I think what I'd like to do is suggest too that we not add any more questions at this point. There's 3 in the queue at this point.
Okay. Email's fine with me. I am old school, so I do like to pick the phone up and talk to people. So if you're in the same generation as I am, if you want to pick the phone up and shoot me a phone call or an email, however you want to do it, then we'll get those questions answered. And as far as time, I'm good till about 4:30.
Okay.
Then
So-
quick on it,
Yep.
yes, you should fly cut both sides of the spool board to get that material off your
Okay.
spool board.
So you're reading the questions in the queue then. Thank you. So that one was, the question was, if you have a fresh sheet of MDF, should it be resurfaced on both sides?
Yes, absolutely. You need to consider how MDF is made. And so I went back to the slide, a word about spoil boards. And if you consider how MDF is made, one of the last processes in making MDF is for that sheet of MDF to go through a wide belt sander. And typically they can take that up to 220, 320, and that actually seals the surface. Makes for a very nice flat panel. But for spoil boards, you have got to open up both sides of that. And typically, we're looking at it skimming a 1/16 of an inch off both sides before we even start to cut parts on that spoil board.
Next question is, how important is a torque wrench, and how often should you change out a collet? So it's a 2-part question.
Great question. So torque wrenches are very important. Sometimes we provide those with new sales, sometimes we don't. The thing about the torque wrench is it is possible to over-tighten a collet. And when you over-tighten a collet, you're turning that collet, you're putting pressure on that collet, and it's actually making that collet now be out of balance. On the SYOZ 25 collets, it's recommended that we go to 90 foot-pounds to torque that tool down. We've been in facilities where the operator has a big 4-foot cheater bar welded on the end of their wrench, and that's how they're tightening their tools. You can over tighten collet, and you can over tighten the collet nut, and you're gonna bind those up, and you're gonna put stresses on those. That there's a reason why, and you've got to go back to the collet manufacturer. As of lately, when I say lately, as of the last 17 years, we've dealt primarily with HSK 63 tool holders and SYOZ 25 collets. The ER 40 collets and the ER 32 collets, those are going to be at a different torque range. Okay. And with that said, you've got to default back to what the OEM or the provider of that collet says it needs to be tightened to. So torque wrenches for us can become a very invaluable tool, because now you're not relying on a guy on how strong the man is. We're relying on somebody to set that torque wrench correctly for the correct foot-pounds, and then they tighten it. And when that torque wrench clicks, we know that it's tight, and we don't need to go any further with it. In regards to when is it time to replace a collet? That's a great question. If you're breaking router bits and you're not replacing the collet, some things that you have got to look at. Typically, when a router bit breaks, if it breaks at the face of the collet, there's a good chance that you have put a burr into that collet. And if you don't replace the collet and you use that same collet that has a burr in it, when you tighten the next tool down in that, you're going to get a hairline fracture in the edge of that cutting tool, and it's going to break prematurely. Collets are anywhere from $22 to $32. Your cutting tools are anywhere from, let's say, $80 to $150 per cutting tool. If we break the tool at the face of the collet, there's a 99% chance you now have a burr in that collet. If you don't have a replacement collet, you have got to inspect that collet and make sure that there's no burrs that are going to impact the edge of that tool. The other thing about the burr is, or the damaged collet, what can happen is that now becomes a balance issue with the spindle. Everything affects the balance of the spindle, whether it's a good cutting tool or a bad cutting tool, whether it's a good collet or a bad collet, whether it's a dirty tool holder or a not dirty tool holder. Everything affects and compounds the balance of your spindle. Don't want you to be afraid of anything, but just be aware that everything that you do to affect how centered the tool is mounted into the collet and the tool holder is mounted into the nose of the spindle, everything, the balance is going to affect everything. It's going to affect cut quality, it's going to affect the life of your spindle, and it's going to affect the longevity of your cutting tool. So for me, the collet manufacturers say that you need to replace the collets every year. Well, that's pretty good if you're the guy that sells the collets. Okay. Where we start to recommend collets being replaced is it a tool that's used day in and day out? Are you using that cutting tool 8 hours a day? Part of running the machine is consumables. A collet is a consumable. Okay, so a yearly basis on collets you're using all the time, that would make sense. But if the bigger part of this is, if you get a bunch of scratches in the face of the collet, or you get burrs in the part of the collet where the cutting tool goes into, you've got to fix that first. Is an example, we've had customers, they'll break 3 or 4 cutting tools. And one of our first return questions is, did you replace the collet? Well, no, we didn't. All right, we need to replace the collet first before you start replacing cutting tools, because chances are that collet has a burr in it, or that collet's got scratches in the face of it. Or let's say, as an example, when we cut toe kicks out on a base cabinet, That leaves a little bit of scrap behind. That scrap can get up and it can scratch the surface of the collet. It's part of running the machine. The bigger part of that is that scrap is kicking against the side of that tool, banging, and then that banging goes up through the nose of the spindle. I can't emphasize enough, for your standard cutting tools is to have a couple of backups of collets for those cutting tools. Not only that, have a couple of backup collet nuts so that if you damage a collet nut, you can easily replace that and you've got one on the shelf and you're ready to go. I'm not sure if I answered that question the way it needed to be answered.
It sounded pretty complete. All right, next question we've got here is looking for suggestions on where to start to troubleshoot a problem. The issue is that our CNC has areas where it will predictably not cut all the way through. It's a 5x10 bed, and the last 16 to 20 inches on the right side will rarely cut all the way through, while the left side cuts clean as it should. They've got a new spoil board, surface spoil board, but it doesn't matter what material or tool, it always leaves an onion skin in that space. So how should they troubleshoot that?
That's a tough one. So it sounds like there could be a couple things going on there. You could have an issue with the machine itself, meaning that the first thing that we would look at would be, is the machine level? If the machine is built correctly, we've had machines that are a half of an inch out of level and we still get a flat spool board. And this is not a jab at any machine, but there's a reason why machines are built at different price points. Okay. I don't know. I know you got a 5x10 bed. It sounds like there may possibly be a twist in the frame of the machine. When you fly cut, is it fly cutting all the way through? Or when you fly cut the new spool board, is it getting fly cutted all the way across?
Let me unmute Steve and see if he can add to that for you. Steve, I'm going to hit unmute. You should be able to talk when you confirm.
Steve, so my return question is when the spool board is new and you fly cut it and you fly cut both sides of it, is it getting fly cutted all the way across, or is there parts that aren't getting fly cutted?
He may be just relying on the recording at this point. I'm not sure. So
Okay.
Don't have an answer. We'll move on to our last question then. If Steve comes back, just put something in chat, Steve, so we know you're back, and we'll come back to you. Muted myself. So Lee has a question piggybacking on the vacuum question from earlier. He says he cuts a lot of MDF doors running a single phase vacuum pump and gets around 7 inches of vacuum. Says we sometimes have an issue where the sheet has a slight bow in it and struggle to hold it tight to the spoil board. Would switching to a Becker 10 horse pump improve this? Because currently they have to use brad nails to keep the sheets tight, and they don't want to do that anymore.
Yep, I think. All right, so he's on single phase, right?
Lee, I'm going to unmute you if you want to answer Jim's questions.
Hi, Jim. Can you hear me all right?
Really? Yes, sir.
Yeah, so we are on single phase. We have 400 amp single phase service. We do have 3-phase equipment that we run both rotary converters and digital VFD converters on. So we have the ability to run the Becker 3-phase pump with a converter.
Okay. So I think that's going to help. Are you currently running what's called a regenerative blower?
I believe so.
Okay. So that should make a big difference, meaning that it should improve the problem that you're having. If it's a regenerative blower, the problem with the regenerative blower is once the vacuum loss is there, it's very hard to regain that. Where with either a Becker pump or even a liquid ring pump, that pump's going to work as hard as it possibly can, even with air loss. Okay. Going to a 10 horsepower Becker from what you currently have should be a big improvement. However, you may need to go to a twin pump system. And that's probably not necessarily what you want to hear, but that may be what you need to do. Is if you have the available power, which it sounds like you got plenty of single phase there, if you have a phase converter that can handle that amount of amperage, even going a 10 horsepower Becker is going to be much better than what you have, if I understand what you have, which
Right.
is a regenerative air blower.
So the pump that we
Replacing
have has 4 motors in it, 4 separate motors, 4 separate pumps built into this
Wow.
proprietary case.
Okay.
And we get a maximum of 7 to 8 inches of vacuum, depending on the atmospheric, conditions, of course. And that at times, because we do flip side ops on our doors, we back pocket a lot of our doors just to help with the flattening of them and keeping them flat for our clients. We can't just necessarily flip the sheet so that it's, crowned in the center and then sucks down
Yep.
tight. That certainly
Yep.
does work, but when you're machining both sides, one side's going to be a problem with it. So we've contemplating, getting an entirely new machine that has a Becker along, built in with it. When we bought this, it's a 4x8 machine, so we're not talking a giant area. When we bought this, we were told we could only get this single phase 4 motor pump and run it. It was never, we were never offered the option to potentially get a Becker with a phase converter. But the cost of a new machine compared to just the cost of a new pump is obviously significantly less to do the pump. But there's other issues as well that come along with this lighter weight machine to begin with. So that's kind of where we're at here is like I said, right now we'll put a sheet on, we square cut it, push it up against the pins, do the backside, flip it back over, and usually have to take and put 5 brad nails down each side and 1 on each end to keep it so that it's tight to the spoil board, because as you know, once it lifts off the spoil board, even just a 1/16 or a 32nd of an inch with our pump, it just kills it, and then the whole thing lifts off.
Game over.
Game over. And if it does that in the middle of a tool pathing, then the entire sheet of doors is now garbage, and your time and material money just went out the door.
Yep. So some questions to help conserve vacuum is on the edge of your spool board. Are you sealing that up with anything?
Yes, we're sealing that up with wood glue all the way around. We put a tight bond, 2 layers of tight bond all the way around that. We've looked at possibly going with some gasketing for under the spoil board, because there's for each of the 4 zones. Some people have suggested trying the all-star gasketing on top, but I have concerns about that, because it's a compressible material, and with the MDF doors, a few thousandths matters.
Oh yeah. Yep. So one thing, and you may or may not have tried this, in lieu of using brad nails, and I'm only trying to come up with a way to work around your current issue. Have you tried to seal the gap between the parts in the spoil board with either painter's tape or masking tape? Have you tried that?
When we put a sheet on, put some
so
tape around between the 2.
After you do your initial cut, before you flip it, after you flip it, have you tried to tape seal the edges up?
No, not between the material and the spoil board. We haven't tried that.
You might give that a try. That may conserve some of your vacuum. The only reason I'm recommending painter's tape, we've seen companies in the past use packaging tape, and the problem with the packaging tape is as soon as the router bit cuts through it, that tape sticks to the cutting tool, and now you've got a tool out of balance.
Yep.
When we've seen companies use either blue painter's tape or green, the color doesn't matter. but it's easy for the router bit to cut through that and not have it get wrapped around the router bit.
And that makes sense.
And we've taken occasions where we had a thing come up, I don't know, it's 15, 16 years ago, where we were cutting 5/8 thick plate aluminum. And we had a 25 horsepower liquid ring pump hooked up to the machine. And the guy brought me 5/8 thick plate aluminum that was a 4 foot by 8 foot sheet. And I kid you not, the sheet waved at you. And when we put that plate aluminum down on the machine table, we had gaps that were 1 inch all the way around. Not all the way around, but we had 1 inch gaps that would wave across because the plate wasn't flat. And we had to cut parts and we had to get the job done. And so I went and got some 2-inch painter's tape and I started working my way around the whole edge. I didn't like doing it, but this is the material they gave us to cut. And by the time we were done, we had that 5/8 plate aluminum sucked down flat. Now that created other challenges with machining that part out, because as soon as you start to cut it, that panel relieves itself.
Right.
And that helps relieve the pressure in the panel. So I don't like doing onion skins, but we skinned the whole thing, relieve the panel, and then we were able to machine the rest of the panel. So that little trick of tape sealing the edge of the spool board and to close that gap up in lieu of using brad nails, that's going to be a temporary fix. But I think a 10 horsepower vacuum pump is going to be miles ahead of where you're at right now.
Okay, and that's kind of the impression that I've gotten from others as well. And it was just I saw the question about the vacuum and just wanted to kind of piggyback on that as well. So like I said, it does well and it holds 99% of the parts, especially when we do a full onion skin. But it's getting that initial hold down seems to be a bit of a headache for us. And it's to the point that we just, every time we do it, we'll wind up, we set our parts in far enough that there's a border all the way around that we can, brad nail into and not worry about running our tooling into it.
Okay.
So thank you.
In the old days, and I appreciate the question, in the old days when CNC routing was new and this whole nested base environment came to play, on systems where we didn't have a decent vacuum pump, we found these plastic brads that we would use to staple the parts or to nail the parts down. So if you have to shoot the part down with nails or screws, you might be able to find a plastic screw or a plastic nail that would work for that. So when you do cut through it, it's not going to be detrimental to your cutting tools.
All right. Okay. Thank you, sir.
Yes, sir. Thank you.
Steve responded. I think he should be available now. He was just not in a quiet area, so we'll let him ask his question about onion skinning. Steve, if you're there, you should be able to unmute. I see he's still with us. He said he'd circle back when he's able, so it may not have been possible. So that was the last question that we had in queue. And, appreciate you staying longer than we planned, Jim, to do that. And certainly for everybody who's still with us right now, too. Thank you for sticking with us on this. Sounds like it was helpful information for you. What happens next is we will be sending out an email tomorrow that contains the link to the recording for anybody who wants to go back and revisit anything. We will probably include a little survey in there too, asking for your thoughts around a couple of future topics that we'll put out there. And, certainly if you have other questions for Jim, best way to reach him is jim@descncrocks.com. You'll see that in the email that goes out tomorrow too. And for those of you who had asked for information about the cleaner and things like that, we've made notes of that, and we will make sure that the DES team follows up with you on getting you that information. Jim, any final comments?
No, other than maintenance doesn't have to be dreaded. It doesn't have to be hard. It just has to be done.
There's the quote for the day. All right. Well, thank you everybody for joining us. We appreciate it, and we'll see you next time. Thanks, Jim.
Thank you all.